and welcome to Matrax channel. In this video, you will learn about the geometric sequence. Specifically, you will learn about the definition and identifying geometric sequences. Let us start with the definition of geometric sequence. A geometric sequence is a sequence where each new term after the first term is found by multiplying a non-zero constant to the preceding term. The constant number is called the common ratio. To further understand the definition of the geometric sequence, let us consider this example. And here is the situation. Suppose you have started to save 1 peso on the first day, 2 pesos on the second day, and 4 pesos on the third day, and each day after, you always double the amount of what you have saved on the previous day. Here, we are expected to make a list of your 10-day savings. Now, in this situation, you're already given with the amount of saving for the first day, and that would be 1. While on the second day, it was stated here that you have saved 2 pesos on the second day, while 4 pesos on the third day. So at this point, let us consider first what happened on the first 3 numbers. Here you will notice that we can come up with a 2 by either adding a 1 from 1 or multiplying a 2 with 1. So for the meantime, let us note what may have happened here. But if we take a look at the next consecutive numbers, 2 and positive 4, then we may obtain a 4 from 2 by either adding a 2 or multiplying a 2. But since it happens to be constant when we are using the multiplication of the preceding number with 2, therefore, let us try to eliminate the first idea. So here, we have multiplied the 1 with this 2 so that we get the next number 2. While if we do the same for this 2, multiplying this with 2 gives us the 4. And let us see whether the rest of the numbers here can be actually determined by using that same idea. Going back to the situation, it was stated here that each day after, you always double the amount of what you have saved on the previous day. So since our previous saving is 4, if we double such amount, then it is the same with the idea of multiplying the 4 with 2. So it gives us the next number, 8. Since it happens that we should do the same for all the remaining days, then multiplying the 8 with the 2 gives us the next number, 16. And it will be followed by 32, 64, 128, 256, and 512. So again, we merely get all these numbers by multiplying the preceding number with a non-zero constant 2. And this is an example of a geometric sequence. And based on the definition, the non-zero constant being multiplied to the preceding number is what we call the common ratio, which is usually denoted by R. And it happens to be the 2. So here, that is our common ratio. And now, let us proceed with the next part of this video, identifying geometric sequences. And here is an example. Identify if the sequence is a geometric sequence and indicate the common ratio if the sequence is a geometric sequence. So you have learned from the definition that in order for a certain sequence to be a geometric sequence, then there must be a common ratio. So the common ratio is the number being multiplied to the preceding number so that it gives us the next number. But we may also work on this backwards by using, of course, the inverse of multiplication, which happens to be the division. So if we take a look at these two numbers here, by dividing the negative 8 by negative 4, then we will obtain a certain quotient, and that would be a positive 2. And if we do the same with the negative 16 divided by negative 8, the answer will also be a 2. And this will also be equal to 2. Since all of these numbers are the same, then the common ratio is equal to 2. And this is an example of a geometric sequence. And let us have the next. So we merely have to use the same idea. So 6 divided by negative 2 is negative 3. Negative 18 divided by positive 6 is negative 3. 54 divided by negative 18 is also negative 3. Since all of these are the same, therefore we have a common ratio which is equal to negative 3. And this is a geometric sequence. And let us proceed with this. Dividing 7 by 7 gives us 1. Dividing 7 by 7 is also 1. And this will also give us a 1. Since all of these are the same, therefore the common ratio is 1. And this is a geometric sequence. And let us proceed with this one. So doing the same, 1 divided by 3. So since we do not have an exact answer, therefore we are writing this as a fraction, 1 over 3. And now we have to divide 1 over 3 by 1. So if you are not familiar with the process on how to divide fractions such as 1/3 by 1, then I have a video dedicated for fractions. So please try to visit the video first before moving on to this example. And now, dividing 1 over 3 by 1, so it only tells us to copy your numerator and multiply this with the reciprocal of your denominator. So multiplying this gives us 1, while multiplying this gives us 3. So the answer would also be 1/3. And now we have 1 over 9 divided by 1/3. So again, please try to visit the video about fractions. So we have 1 over 9 divided by 1/3. So here we only need to copy the numerator and multiply the reciprocal of the denominator, which will be 3 over 1. And multiplying this gives us 3, while this one gives us 9. But notice that we can write the fraction 3 over 9 in lowest terms, which happens to be 1/3. So since we all have these numbers to be the same, therefore, we have a common ratio. And this is an example of a geometric sequence. And now let us proceed with the next. So here we have our 0 divided by 1, which happens to have a quotient of 0. So please do remember that when a 0 is divided by any number, the quotient will always be a 0. But here we have a 0 divided by another 0. So anyway, this number cannot be 0 because there is a special rule for that. So when a 0 is divided by a 0, the expected answer is indeterminate. And to complete this idea about division that includes 0, then we may have any number be divided by a zero. So when this happens, a certain number like 10, when divided by zero, the answer is undefined. Since that the numbers being divided here are zero and the other zero, then it would be indeterminate. Since we already have different answers here, therefore, this is not an example of a geometric sequence because there is no common ratio. And now let us proceed with problems related to this geometric sequences. So here, we are expected to answer each problem related to geometric sequence. Show your solutions if necessary. So here the question is, what is the next term in the geometric sequence? So the general idea is to come up with a common ratio so that we know what exactly is the number being multiplied with this last number, 54, to give us the next number. And regarding the common ratio, we can easily do that since it was already stated that it is a geometric sequence, then we can only perform one operation here by using the a sub 2 and the a sub 1. So dividing 6 by negative 2 gives us negative 3. And this will already be your common ratio because it was stated that it is a geometric sequence already. And now to determine the next number, then obviously we have to multiply the common ratio of negative 3 with the 54. So 54 times negative 3 gives us 162. So therefore, the next number would be 162. So we may also have questions like this. What are the next two terms of the geometric sequence? So again, we merely have to apply the same idea. We can easily obtain a common ratio by dividing 1 by 3, which is 1/3. And now we have to multiply the 1/3 with 1 over 9 to give us the next. Okay? So we have our 1 over 9 multiplied with 1 over 3, which gives us 1 over 27. So the next number would be 1 over 27. And this is one of the two answers. So obviously, by multiplying that same common ratio of 1/3 with 1 over 27, it gives us the next number. So 1 over 27 times 1/3 gives us 1 over 81. And that would be the next number in the sequence.